All right. So, how fast is the butterfly moving in this picture? What is the direction uh, that it's moving in? To describe motion, you must state the direction the object is moving as well as how fast the object is moving. You must also tell its location and a certain time. In other words, when we study motion, we have to think about all these things. So, what is needed to describe motion completely? One thing we're going to talk a lot about is a frame of reference. A frame of reference is a system of objects that are not moving with respect to one another, is one way to word it. To describe motion accurately and completely, the frame of reference is necessary. How fast are you moving? How fast the passengers on the train are moving depends on the frame of reference chosen to measure their motion. Relative motion is movement in relation to a frame of reference. As the train moves past the platform, people standing on the platform will see those on the train speeding by. When the people on the train look at each other, they don't seem to be moving at all. More importantly, those of you guys sitting in your desk, you think you're sitting still, but really the earth is rotating on its axis, and then it's orbiting the sun, and the galaxy is spinning, and the universe is expanding. So we're all moving. It just depends on our frame of reference. So, to someone riding on a speeding train, others on the train don't seem to be moving at all. In other words, this man and woman, they're not moving relative to each other, but they're moving relative to what's going on outside the train. Which frame should you choose? When you sit on a train and you look out the window at a treetop, that may help you see how fast you are moving relative to the ground. If you get up and walk towards the rear of the train looking at a seat or the floor, shows you how fast you are walking relative to the speed of the train. Choosing a meaningful frame of reference allows you to describe motion in a clear and relevant manner. How are distance and displacement different? Well, distance is the measurement. It's the length between 2 points. Or this is going to be on your study guide, so remember that. Displacement is the direction of the starting point and the length of the straight line from the starting point to the ending point. Distance is the length of a path between 2 points. When an object moves in a straight line, the distance is the length of that line connecting the object's starting point and ending point. The SI unit for measuring distance is meter. Very large distances, and sometimes we use kilometer, but it's important to note that the standard unit, SI unit, is meters. So kilometers is like a mile, but it's not quite. But in the SI unit, the standard one, the one that we need to do all of our equations, will be in meters. Distances that are smaller than a meter, we use centimeters. So centimeters is kind of like inches. To describe the object's position relative to any given point, you need to know how far away and in what direction the object is from that point. Oops. Displacement provides that information. Think about the motion, and let me talk about, um, I'm just going to stick to the script here. Think about the motion of a roller coaster car. The length of the path along which the car is traveled is the distance. The displacement is the direction from the starting point to the car and the length of the straight line between them. After completing the trip, the car's displacement is zero. I really wish we had a graphic on that. How do you add displacements? Well, displacement is a vector quantity. So a vector is a quantity that has a magnitude and direction. Also on your reading guide today, make a note of that. So we add this with vector addition. Displacement is an example of a vector. The magnitude is the side length or amount. The arrows on the graph or map are used to represent vectors. The length of the arrow shows the magnitude of the vector. The vector addition is combining the vector magnitudes and directions. The displacement along a straight line occurs when two displacements represented by two vectors have the same direction. You can add their magnitudes. If the two displacements are in opposite directions, then you would subtract them from one another. So here's an example of what I'm talking about. If we add the magnitude of two displacement vectors that have the same direction, what we're going to do is you just add them up, right? So the car goes forward 4 kilometers and then goes forward another 2 kilometers. So the total displacement is 6 kilometers. But now in part B, if I move forward 4 kilometers, then move backwards 2 kilometers, think of a number line. The 4 is positive because it's going in the positive x direction, and the 2 is negative because it's going in the negative x direction. So it's really 4 minus 2, and that gives me the displacement of 2 kilometers. Displacement is important and different than distance. And we're going to go over lots of examples of that. Displacement isn't along a straight path. When two or more displacement vectors have different directions, they may be combined by graphing. So look at this example. Measuring the resultant vector, the diagonal red line shows the displacement from the boy's home to his school is 2 blocks less than the distance that he actually traveled. So this is the path that he walks to school, right? So this would be the distance that he walks. He walked one, I'm assuming this is a block. 1 block, 2 blocks, plus another 2 blocks, that's 4 blocks, plus 3 blocks, that's 7 blocks. That's the distance that he traveled. But the displacement is only 5 blocks because it goes from the starting point to the end point. So that's really the difference between displacement and distance. In physics, we use displacement most of the time, but there are times where we do use distance. The boy walked a total of 7 blocks when we sum the magnitudes of each vector along the path. But the red is called the resultant vector, which is the vector of the sum of 2 or more vectors, right? The resultant vector points directly from the starting point to the ending point. And that's it for today. I'm going to go through, we're going to do a worksheet on all these at some point. So I'm not going to do the assessment questions today.